As you already know, I rebuilt the valve body in my garage. I set up a table which piece of 3/4 plywood. It's less than knee height, and I have the floor of my garage super clean, so if anything fall on the floor I could find it very easy. I also use cardboard to soak the oil and also to be soft surface so it doesn't scratch the machine surface of the valve body. I still have some label left. The way I made this on notepad in my computer, I put this number and I put enough spacing between these numbers so I could, when I cut them, I have enough room. And I did laminate them and tie wrap them to the bolts and to the connectors, and then I drew it on the paper so I could put everything back the way it came out to minimize stress and gas and all that. I used number 21 drill bit to clean the bushings of the solenoid. You can use 4mm too. Just make sure the drill bit is brand new so it will cut easy and clean, and also it doesn't have damage from a drill chuck. When I cleaned the solenoid, after I cut it with the drill bit, I inserted the armature into the solenoid while it's lubricated with mineral spirit, and I blew it with air, let the armature spin real fast, and that helped polish the bushing so the armature will work even smoother inside the solenoid. You're also going to need a 9-volt power supply. Just make sure it's rated for more than 1 amp. This one rated for 1600 milliamp or 1.6 amp. These 6 solenoids, you have to touch one lead to each pin of the solenoid and the solenoid will energize. These 2 over here, the coil of the solenoid, one leg of it is connected to the case and the other one to the pin, so you have to touch the case and the pin to activate it. Make sure you be away from the cleaning area where you have the mineral spirit and the brake cleaner and all that, and make sure the solenoid and your hand completely dry and clean, so when you activate the solenoid the spark doesn't create fire hazard. I also took 2 pins, one that work with these 2 solenoid and one for these 6, and I just sanded that lock mechanism off, so, and wire the adapter to the connector like this and use electric tape to isolate them. And this is how I tested the Beetle solenoid. It was way easier than try to line the wire with the pins. If you don't have a lathe and you want to rebuild your solenoid, just make sure you buy a 28-inch ID thick wall pipe and then sand it until the solenoid fit inside it perfectly. You can drill it with 1/2-inch drill bit and then cut it with the grinder so the connector of the solenoid will fit through it. You can weld washer or something on the other side of the pipe, and then you could use washers for shim to when you round the case and when you crimp it. I'm going to provide you with the dimension of these tools, and you could use it to build your own tool. We start with this part. The outside diameter of this round stock is 1 3/4 inches, about 44.5 millimeter. The length of it is 2.5 inches or 63.5 millimeter. I bored it all the way through to 1.110 inch, about 28.194 millimeter. And then I welded the plug over here, and the depth of it now is 2.080 inch or 52.832 millimeter. I drill it over here, or I drill the plug with 13 millimeter drill bit, or it's about 0.512 inches. The slot over here to allow the connector of the solenoid to fit, it's 0.480 inch or about 12.192 millimeter. and the depth of it from here to here is 1.315 inch or 33.401 millimeter. The dimension of the crimper, same thing, is 1.75 round stock or 44.5 millimeter. The center hole, I just use a 3/4 inch drill bit, and this allow all these solenoid to fit inside. It's about 19.05 millimeter. You could use just 19 millimeter drill bit. The chamfer, I just use 1.25 drill bit, and I kept drilling it until I got to the dimension of 1.160 inch or 29.464 millimeter. One end, like I said, I just use the drill bit to do this chamfer. On the other side, I use the compound on the lathe to make it deep, so I could, when I start the crimp, it will push the case in, and it will prepare it for this one to crimp it all the way. I also made a small slot on both ends because the connector is stick above the case of the solenoid. The width of it is 0.480 and the depth of it is 0.125 or 1/8 inch. In metric, it's about 12 millimeter wide or 12.192 millimeter, and the depth of it is a 3.175 millimeter on both sides. This one over here, I just used 1.125 round stock. I machined it down to match the dimension of the valve or snout, the greater size, 1.053 inch or 26.746 millimeter. I just did this part over here. You probably don't have to go as deep as I went. This much will be plenty enough, or about 1/4 inch. Lengthwise, it's 5 inches or 127 millimeter. This rod over here, I used it to extract the solenoid if they wedge in after the crimping or extraction. It's just 1/2 inch round stock, and I cut it to 6 inch long, so it's about 12.7 millimeter diameter and about 152.4 millimeter long. I made 4 shims, different thickness. I ended up using the thinnest and the thickest. They both measure 1.104 inch in diameter or 28.042 millimeter. The thickest I used to crimp the solenoid, it measured 0.467 inch or 11.862 millimeter. The thinnest I used to extract and also to round the solenoid casing is about 0.367 inch or 9.322 millimeter. When I used the thinnest shim, this will make the solenoid, after I open it, it will make all the way and it be flush over here. If you don't have access to lathe to make this tool, you could use the plier to round up the case. I use this over here and hammer it in, and that will cause the case to take the dimension of this from the outside and this from the inside. This is just alignment plier. I ground it with the grinder to match the roundness of the solenoid, and then the other end I just made it extend longer by grinding this more, and this will allow it to hold into this tool. If I do it all over again, I will take a file and I will cut small groove over here, so this will bite better on the case and it will not slip. Another thing I will do different, I will cut lip over here about 1/4 inch deep, and then I cut the opposite on both ends of the crimper, so this will go inside without it moving to the sides like this. So it will go and it will register straight. But this did fine. If you are going to manufacture your own tool, you probably need to buy a caliper. You could buy something similar at Harbor Freight for less than $10. And this one will measure both in standard and in metric. It is very important to torque the bolts to specification. If you under torque the bolts, they may get loose and that will cause the valve body to leak. If you over torque it, it may cause the bolt to break, and then you have to dismantle the valve body again to extract the broken bolt. Sometimes if you over torque something like this, you may deform the parts of the valve body and that will cause leak. So make sure you follow the specification provided by the factory. I included all the specification throughout the videos of this tutorial. As I mentioned in the first video, there could be several other problems that will lead to hard shift when the transmission warmed up. One of them, you could just have a bad temperature sensor. Depending on the temperature of the transmission fluid, there is resistance inside this. It will send different reading to the TCM. And based on the temperature of the fluid, the TCM will regulate the pick and the drop time of the solenoid to compensate of the thickness of the transmission fluid. Because as you know, the transmission fluid, when it's cold, it's thick, and as it warm up, it's become thinner and thinner. So the TCM will compensate the pick and drop time based on the temperature reading it gets from this sensor. And this held in place by this bracket. Let's go around it like this and keep it in place with this bolt. I verified this temperature sensor was good on the Beetle before I did the valve body work by monitoring the temperature of the TCM with VCDS, and I was taking reading from the transmission itself with this tool. So I know the sensor was good because both reading, they were very close to each other when the transmission was cold and when the transmission warmed up. Very smooth shifting. Good luck fixing your car. Merry Christmas and Happy New Year.